Hello students, welcome to Sunya IAS. So today we are going to discuss more questions of CSAT, and since the topic for today is mensuration, so don't get afraid, because generally people have the idea, okay, a lot of formulas are there in mensuration, lot of formulas, but as you can see, this is our online course and we have our offline modules as well. In all these courses, we have that approach that no one is actually scared of the formula anymore. Okay, we actually focus on the part that how actually number one the formula comes about, so that you can actually understand the formula rather than memorizing it, and with all the practice we bring the formula into the flow of your nature so that it becomes a part of your second brain. Okay, so before applying the formula you do not have to think about it, you just know the idea behind the formula and the formula is there. Okay, so that is the technique we follow in mensuration. And now we can begin the discussion for today's questions. Okay, before starting the mensuration, area, volume, all those topics, we'll just have basic discussion about units. Okay, so if we talk about volume, we have the unit of meter cube, and we have one more unit called liter. So one very important relation is there between meter cube and liter, and that relationship is 1 meter cube is actually equal to 1000 liters. Okay, so you know that there are 1 liter bottles of cold drinks and mineral water and what else. So suppose if one bottle is of size 1 liter, then in order to fill a bigger tank of 1 meter cube volume, you will need 1000 bottles to fill it up. That is the basic idea. Okay, so 1 meter cube is nothing but 1000 liters. Based on it, we can solve this very easy question. So the question says a cubical vessel of side 1 meter is filled completely with water. How many milliliters of water is contained in it? Okay, so you know that if a vessel is cubical, what is the volume of cube? It is nothing but A cube, where A is the side. Here you can see side is 1 meter. So the volume is going to be 1 into 1 into 1 meter cube, simply 1 meter cube, right? And now we have to find this particular volume in terms of not liters but milliliters. So we'll first convert it into liters. So 1 meter cube will be simply 1000 liters, as we saw earlier. Now what about milliliter? So you are aware of the term millimeter. Millimeter is nothing but 1 by 1000 meter, right? We can also write it in reverse, that 1 meter has actually 1000 millimeters, mm. Same thing will be applicable for the liter part. So for 1 liter, you can say 1 liter will contain 1000 ml or milliliters. So just write in this part, you can say 1000 liter, and further you can write it like this: 1000 liter and 1 liter is nothing but 1000 ml. So overall we will have 1000 into 1000, 10 to the power 6 milliliters, and that would be the final answer. That is 1, 2, 3, 4, 5, 6. Option number D would be the correct option in this case. Okay, so please be aware of the number of zeros. Correct option here would be option number D. Okay, so it was a pretty easy question just based on units. Now the next question says that 1 liter of water weighs 1 kg. So 1 kg is the weight of 1 liter of water, it is being asked. Okay, then how many cubic millimeters, that is basically mm cube, millimeter cube of water will weight this much amount? So the question is seemingly quite complicated because there are different kinds of units involved. First we have liter, then we have kilogram, then it is asking in how many cubic millimeters you will actually get 0.1 gram. That is the question. Okay, so in this question you need two things. You must have the basic idea of units. After that you must apply the unitary method. Okay, so simply I can say if 1 kilogram is containing 1 liter of water, Let us try to convert it into first meter cubes. The liter part will convert it into meter cube. So if 1000 liter is equal to 1 meter cube, then 1 liter is equal to 1 upon 1000 meter cube. Is it clear? 1000 liters make up 1 meter cube. So 1 liter will be only 1 upon 1000 of a meter cube. That is, here you can write this is nothing but 1 upon 1000 meter cube of water. Okay, in 1 kg. After that, we have to convert this meter cube further into millimeter cube. So for that, what we will do, we will do a simple thing. We know that 1 meter contains 1000 millimeter, right? 1 meter has 1000 mm. So how much millimeters will be there in 1 meter cube? So in order to get 1 meter cube, what we do, we just take a cube here and take a cube here. Here we will get 1 meter cube, and that would be equal to 1000 cube. That is 1000 into 1000 into 1000. Let me just write it again down here, millimeter cube. So 1 meter cube actually contains 10 to the power 9. There are overall 9 zeros. We can write it like this, 10 to the power 9 millimeter cube. So I'll just write down the following thing here again. So 1 kg will contain 1 by 1000 into 1000 into 1000 into 1000. And what is the unit? So let me just erase this particular part. Overall, I can write that this will be in millimeter cubes of water. You can further cancel these thousands out and you will get and this much amount of water, this much millimeter cube of water is contained in 1 kg of water. Now we have sorted one part of the thing, which is we have converted the volume which is given in liter into millimeter cube, from liter to millimeter cube as it is visible. Now we have to convert the unit of kilogram. From 1 kilogram we have to convert it into 0.1 gram. So now we will work on this side. And now you know that 1 kilogram is nothing but 1000 gram. So 1000 gram contains this much millimeter cube of water. 1 gram will contain divided by 1000 millimeter cube water. So just cancel it out. Further you will get that 1 gram contains 1000 millimeter cube water, but it is not 1 gram we have to find out. We have to find out for 0.1 gram. And finally you can say that 0.1 gram will be contained in 0.1 into 1000, that is 100 millimeter cube of water. And this is what is being asked, that in how many cubic millimeters of water we have 0.1 gram. So that answer is 100 millimeter cube. That is option number C is going to be the correct option in this particular case. Okay, so just I am repeating the process for you. We have to know that 1 kilogram contains 1 liter. Now we have to express the same thing in terms of millimeter cube and 0.1 gram. So first we will go with the volume part of it. We convert liter into millimeter cube. After that we convert this kilogram into grams and further into 0.1 gram, and we get the final answer. So it was an easy question, just you have to be careful in this particular calculation. Okay. Next we have basic questions on the concept of area or the perimeter or the same things like that. So I think you are aware about the things of a rectangle. So I am just drawing a rectangle in front of you, and I hope that you know that this part is called a length, this is called a breadth. Okay, and so area is going to be length into breadth. Perimeter would be how much? It would be the boundary. So length and length, that is 2 times length. Similarly breadth and breadth, 2 times breadth, we get 2 times L plus B as the perimeter of the rectangle. Now there is one more element which is called the diagonal, which goes from this side to this side. Similarly, you have a diagonal on this side also. Okay. So what about this diagonal? If you look closely at this diagonal, let's call it D. So this diagonal is actually forming a right angled triangle. So this is like it is a 90-degree angle here, side D, it is B, it is L. So we can say D square is nothing but L square plus B square. It is the Pythagoras theorem. So how many of you know about it? Pythagoras theorem. Does it ring a bell in your mind, in the back of your mind? So this is something you might have definitely studied in your school. So just having a, what should I say, refreshing of memories for you. So that is the thing for diagonal. Now based on it, we will calculate some, solve some problem on area. So a gardener increased the area of his rectangular garden by increasing the length by 40% and decreasing its width by 20%. So what you are doing, that you are having a rectangle, suppose garden is there in the shape of a rectangle, there is a length L and then there is a breadth B, right? What will be the area? Area of this particular rectangle will be A equal to L into B. Now what you are doing is that you are actually increasing the length by 40%. So you know, in percentage topic we discussed the idea of increasing something by 40%. So if something is increasing by 40%, it is simply you have initial value of 1 plus you have 40%, which can be represented like this, 40 by 100. So you can represent it like this, 1 plus 0.4, here you will get 0.4 and ultimately it will be 1.4 times, right? So here the new rectangle which you are forming, in the new rectangle the length is now greater and it is 1.4 times L. So the new length, let's call it L dash, is equal to 1.4 times L. Now what you are doing with the breadth, you are decreasing the width or the breadth by 20%. So the breadth you have is now decreased. I have told you how to find the decrease. So if something is decreasing by 20%, we simply say the initial value was 1, decreasing, so minus sign, then 20% we express like this, 20 upon 100, it will be 1 minus 0.2, that is 0.8. Okay, so the new breadth will be simply 0.8 times the old breadth. So let me just write it like this, B dash would be 0.8 B. Fine. Now we have to find the new area. New area, let's call it A dash, would be L dash into B dash. L dash came out to be 1.4 L. B dash is 0.8 B. Ultimately we get 1.4 into 0.8, we get 1.12 on multiplication into L into B. This L into B is nothing but the old area. So one can argue that the new area A dash is 1.12 times the old area A. Now reading this particular small equation, can you figure out which option is the correct option? Now it is very easy. So just understand, when there was an increase of 40%, that thing became 1.4. So what this 0.4 is representing? It is representing actually a 40% increase. Now similarly, if we look at this part, it is saying 1.12. We can also interpret it like this, 1 plus 0.12. 1 was the initial amount, plus indicates that there is an increase. And what does 0.12 signify? It signifies nothing but 12%. So overall there will be an increase of 12%. That is option number B is the correct option in this particular case. Okay. Okay, so now after this we'll move on to the next question. 12 equal squares are placed to fit in a rectangle of diagonal 5 cm. There are 3 rows containing 4 squares each and no gaps are left. Okay, So what is the area of each square is being asked. Now this question is a very easy question if you draw the correct diagram. So I request you, please start making diagrams in questions of number 1 speed, distance and time, and also in mensuration. So 12 equal squares are to be fit in a rectangle, and there are 3 rows containing 4 square each. So the arrangement would be something like this. These are the 3 rows, and in each row there are overall 4 squares. So overall you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares are there, and they are together forming a rectangle, and no space is left in between, no gap is there. Now within this rectangle you can see, if each square is of side A, so this would be A, this would again be A, and here you can see it is A and A. So in this particular rectangle we can observe the overall length will be 4 times A, right, and the overall width will be 3 times A. All this information is visible just by making the diagram and nothing else. After that we can see there is a diagonal, and the diagonal is said to be 5 centimeters. So let us assume this is the diagonal, and this diagonal is 5 centimeters. So what we'll do is just use Pythagoras theorem in this particular case. We will say 3a squared plus 4a squared is equal to 5 squared. So there is this side and this side, both of them squared and added would be equal to the largest side, that is 5 square, right? Just expand it further. Here you have 3a squared, that is 9a square, plus 4a squared, that is 16a square, and it is equal to 25. When we add these two expressions we get 25a square is equal to 25. From here you can simply say a is equal to 1 centimeter. And if a is equal to 1 centimeter, one can say the area of each square is going to be how much? 1 into 1, that is 1 centimeter square. So the correct option is going to be option number C. So it was a pretty easy question if you can draw the diagram correctly and just read the question perfectly. Okay, moving on. We have this question. Now this question is based on an hit and trial approach. Let us read it. An agricultural field is the form of a rectangle having length x1 meters and breadth as x2 meters. Okay? And both are variable. We do not know the exact value. But one thing we know is that x1 plus x2 is equal to 40 meters. So then the area of the agricultural field will not exceed which of the following values? Basically it is saying that area will not exceed which value? Simply it is saying, in other words, it is saying what will be the maximum area. What can be the maximum area of the field? Is it okay? So the language is somewhat, off cultured. It says area will not exceed which value, but simply it is saying what is the maximum possible area of such a rectangle. So simply we know that if we have a rectangle, we have a length, we have a breadth, then we get an area, right? If suppose length is x1, breadth is x2, and x1 plus x2 is following the relation of x1 plus x2 is equal to 40. This is the limit. So what we can do is just we can try for different values of x1 and x2. That is what we have to do. So if we put x1 as equal to 1 meter only, so x2 will be equal to 39 meter. Sum is equal to 40. Okay, in this case area comes out to be 39 meters square. Other case which we can take is, let us take the length to be 5 meter. The other side will be 35 meter. The area will be 5 into 35. I think that would be 175 meters square. Okay, that is also one value of an area, right? Then after that we have, let's say 10 meter and 30 meter. Okay, When we take these values of x1 and x2, we get the total area as 10 into 30, 300 meter square. Now let us take both of them as 20 meter and 20 meter. In this case, the area will come out to be 400 meter square. Okay. After that, as you go further, let us make this as 30 and this as 10. It will again be equal to 300 meter square. So now you can see it was increasing from 39 to 175, then 300, then 400, and now it has started to decrease again. And when you take this value to be equal to, let's say 1 meter and 39 meter, just reverse of the previous case, the area again falls down to 39 meters square. Okay. So from overall scheme of things, you can say that for different pairs of x1 and x2, the maximum value which we are getting is when both the sides are equal, x1 and x2 are equal to each other, that is 20 meters, and in that case the area will be the maximum, and that would be 400 meters square. So just by this hit and trial technique, one can say the maximum area is going to be 400 meters square. Okay, so that was one more question done for you. And here also you just need to have the basic concepts ready, nothing else. Okay, so it's quite simple. In this question, let us read it. A piece of tin is in the form of a rectangle which has a length of 12 centimeter and a width of 8 centimeter. Okay, so if we talk about the rectangle, what is the information given? Length is 12 cm and breadth or width is 8 centimeter. Now further it says that it is used to construct a closed cube, so the side of the cube will be how much? So are you able to figure out the idea of the question? The idea of the question simply is that you have a rectangular plate like this of tin metal, right? Let me highlight it also so that it is more visible to everyone. So this is what I am doing to make a tin plate so that you can visualize the process. And using this sheet now, what we are doing, that we are cutting different pieces out of it. So we are just cutting various pieces out of it, and we are actually joining them together in order to make a cube. Let us draw a cube also. So using that, suppose we'll make a cube. Okay, so I know this is not so good looking, so let me just draw one another simple sober cube. Okay, so this is more like it. And what we are doing is just simply we are using the same tin plate and joining the cut portions to form a cube. That is the basic idea. So one can understand that the area of this particular rectangle would be totally equal to the overall surface area of the cube. Are you able to figure this process out? That is why I am drawing the diagram for you, so that you can understand that area of this rectangle is nothing but equal to the surface area of the cube. Right? This is the crux of this particular question. Now tell me, what is the surface area of a cube? As you know that if there is a cube, how many faces are there? So in a cube, there are 6 faces, and all of the faces are in the shape of a square. So what is the total surface area of cube? That would be simply 6 times the area, that is 6a squared. The same thing we have to apply in this particular question. Here we will have area of rectangle as 12 into 8. So 12 into 8 centimeter square would be equal to surface area, that is 6a square. Simply you will have, just cancel out the values, you will have t here. A square will be equal to 16 centimeter square, and so side of the cube a is going to be root of 16, that is 4 centimeter, and therefore side of the cube we found out as option number C, 4 centimeter. So I think it was a pretty easy question. Just you have to figure out this part which I have drawn very beautifully for you guys. Okay. So now we have problems related to volume. So let us see. Okay. So I hope you know the basic idea that the volume of a cuboid is nothing but length into breadth into height. Very simple formula, nothing much to worry about. So now we have this particular question. A village is having a population of 4,000. So what is the population of the village? It is 4,000 people, and it requires 150 liters of water per head per day. So what is the water requirement? 150 liter per head or per person, same thing, per day. So what is the overall water requirement of the village of all these 4,000 people? So total water requirement would be 4,000 people into 150 liters per day. So now we'll have the thing in liters per day. Do not actually multiply it, just leave it like this. So this is the total water demand per day in liters. Now the village has a tank which measures like this, 20 meter into 15 meter into 6 meter. Okay, so what is the volume of the tank? It is 20 into 15 into 6 meter cube. So the water of this tank will last for how many days? So the thing is, if the tank is filled completely, for how many days it will be able to actually provide drinking water to the, or whatever water is there, for whatever needs to the particular village. So here we have the volume. Now this volume is in meter cube here, and here we have this demand in liters. So let us convert this meter cube into liters. Simply we will have 20 into 15 into 6 into 1000 liters. That is the volume in terms of liter. Now what we have to find the number of days. In order to find the number of days, we will simply say number of days will be simply the overall volume of the tank, divided by the daily water requirement. Okay. So volume of the tank we calculated as this. Let me just write it down somewhere else. Let me just create some more space. So we had number of days as equal to volume of the tank, which is 20 into 15 into 6 into 1000 divided by daily water requirement, that is 4000 into 150. Both of them are in liters. After all cancellation, so we can cancel out this 1000 with this 1000. Then further we can cancel out this from this. A 0 can be cancelled out this way. Overall, when all the cancellation occurs, you will get total number of days as 3 days. Okay. So correct option will be option number B, that is 3 days in this particular case. Okay. Now after this, we'll actually move to the second last question of the day, and in this question one more concept will be required, which I am going to tell you. That will be the volume of a cylinder. Okay, what is the volume of a cylinder? Let me draw a cylinder for you. So this is a cylinder. As you can see, there is a circular base and it has some radius r and it has some height h. Generally, if there is any formula for volume, that is simply equal to the area of the base, area of this circle into this height. So what is volume? Volume is nothing but the area of the base. Now here the base is circular in shape, so we write area of the circle into height, that will be the volume, right? So what is the area of a circle? That is nothing but pi r square. Height is simply h. So we have the formula as pi r square h, that is the volume of a cylinder. And the value of pi you can have either 22/7 or you can take 3.14 depending on the situation. So this is the basics which will be required to solve the question. Now let us come back to the question now. Here it says that a cylindrical overhead tank of radius 2 meter and height 7 meter is to be filled from an underground tank of this size 5.5, 4 and 6. Okay. So let me just draw the condition here. First we have an overhead tank. So you might have seen such tanks somewhere in your city or your town. So this is actually an overhead tank which is cylindrical in shape. Let me write it OH tank, overhead tank. Here the radius is 2 meter and the height is 7 meter. Then we'll talk about the underground tank. Okay, this underground tank is actually cuboidal in shape and we have the dimensions as 5.5 into 4 into 6. Now it says that how much portion of the underground tank is still filled with water after filling the overhead tank completely. So suppose there is water filled up in this particular underground tank and suppose it is full, right? And what you do now, using this underground tank, you are filling up this overhead tank with water and it is getting filled with water at some time. After the overhead tank is filled, obviously the water level here will decrease, it will go down to this level. So we have to just tell how much portion of water will be still left in this case. Okay, so what we have to do is just we have to find the volume of this overhead cylindrical tank. We have to find the volume of this larger underground tank and then we have to find the amount of water left, as simple as that. So how much is the volume of OH tank? That is equal to, simply, since it is a cylinder, we have pi into r square into h. Pi we can take 22/7, r we can take as 2, so 2 square into height is 7. After all cancellations you will get the value as 22 into 4, that is 88 meter cube. Okay, then we'll talk about the volume of underground tank. For the underground tank we have the volume as simply length into breadth into height, that is 5.5 into 4 into 6. When we multiply all these values, now you will get 132 meter cube as the volume of the underground tank. So if we fill this much volume from the overall volume, how much will be the volume left? So the volume left will be simply just subtraction 132 minus 88, that is 44 meter cube. So this water left here is nothing but 44 meter cube. So now it is not asking it in terms of meter cubes, it is asking how much portion is left and it is asking in terms of a fraction, as you can see. So we'll just find the fraction and that fraction will be simply, just let me write it here. So here we can see the portion left will be the amount which is left, which is 44 meter cube, divided by the total volume, that is 132 meter cube. Then we cancel out, they will go, and I think you will be left with 1/3. So option number A, that is 1/3 portion will be left, would be the correct answer in this case. And now we'll have a look at the last question of this particular topic. All right. So in this question, be very careful while solving. It is a very easy question. Okay, just take out all the values given here. So let x and y be the volumes and m and n be the masses of two metallic cubes P and Q respectively. So basically we have two cubes, let's call it cube P and cube Q, right? What is the information given? The volume of the cubes is X and Y, and the mass, that is simply in layman terms, the weight of it is M and N. Okay. Further it says that each side of Q is 2 times the side of P. So we can have, if the side of cube P we are assuming to be AP and the side of cube Q we are assuming to be AQ, simply it says that AQ is 2 times AP. Okay. After that it says mass of Q is 2 times that of P. So mass of Q is what? N is 2 times mass of P, which is nothing but M. So we have this one more equation. Finally it says that let U is equal to M by X. So we have a quantity U which is nothing but M by X, and we have one more quantity V which is nothing but N by Y. Okay. So which one of the following is correct? So here there are 4 options which are telling the relationship between U and V. So ultimately in this question what we have to do is to just tell the relation between this U and this V. Okay. So what is U? It is M mass upon X, that is volume. Similarly here it is also mass upon volume. It is simply a way of writing the density. You know the density concept? Okay, so it is the same thing, but that physical concept is not necessary. We have to just find the mathematical value. So here we have to find the relation between U and V. But here we already know that M is equal to, N is equal to 2 times N. So in order to find the relationship between U and V, we need to have the relation between M and N and X and Y. We have the relation between M and N, but we do not have the relation between X and Y. But is there any way in which we can find that particular relation? Yes guys, there is, and here you can see the relation this way. So this is the relation which is going to help us. So now just pay a little attention. We are given, let me use the blackboard, we are given that AQ is nothing but 2 times AP. This is the relation of sides of cube Q and cube P. Now what we want to do is to find the relation between the volumes, since X and Y are what? They are volumes. So in order to get the volumes, what we do here is simply take the cubes of both these values. So when we take cubes on both sides, let me write it there like this, taking cubes on both sides, we have AQ cube is equal to 2AP cube. Here we will have AQ cube will be 8 times, 2 cube will be nothing but 8 and AP cube will be there. We know that AQ cube is nothing but volume of cube Q, and that value is nothing but Y. Okay. And AP cube is nothing but volume of cube P, and that value is nothing but X. So we have the relation that Y is equal to 8 times X. And now we are going to use this particular relation in our question now. So we have one more relation, and the relation comes out to be Y is equal to 8x. Now in order to find the relation between U and V, what we can do is that we can just start from here. We can say U is equal to M upon X. Okay. What is the value of M? Or we can start from that side also. Instead of doing this, we can actually start from here also. We can say V is nothing but N upon Y. What is the value of N? N is equal to 2 times M. So instead of N, you can write 2M divided by Y. What is the value of Y? Y is nothing but equal to 8x. So here you can write Y as nothing but 8x. After all cancellation, you can see V is equal to M by X and divided by 4. So you have 1 by 4 times m by x. Let me write it in just simpler terms. We will have m upon 4x as equal to v. Now from here you can see what is m by x? It is nothing but equal to u. So this value given here m by x is nothing but u. So one can say v is equal to u upon 4, right? And when we cross multiply 4 on the other side, we get u is equal to 4 times v. And therefore guys, this is the relation between u and v, that is option number A is the correct option in this case. This was a very good question, a solvable question. The only thing you have to do is that just neatly write down all the values for cube P and for cube Q. Then use the relations given to you and find the ultimate relation between u and v. So one relation is given directly, n is equal to 2m. Other we have to derive using this part. So just take a cube of this particular equation. You will get this relation, and using these relations, ultimately we get the final relation between u and v, that is u is equal to 4v. That is going to be the approach for this particular question. Okay, so please guys, do not miss such questions. Just hit them in the right manner. And finally, thank you guys, and I hope this session will be helpful to you in the final CSAT examination. Thank you.